So 3, 8, 3, 10 is the concept of a function and a relation. We're going to talk about what the difference between them is. We're going to talk about what's called a diagram map. And then we're going to talk about values of functions, domain and ranges, and the graphs of functions. So there's a lot to define, so I didn't sit here and make you copy everything down, so you have this in front of you already. The first term we're looking at is called a relation. And a relation simply maps what are called inputs with outputs. For example, how many, we have a couple track runners here, don't we? I remember there were a few of you that left, 3 of you for the track that day. So in track, right, some days you have better runs than others. Hannah, what's your best run time? What's the race you're running again, Hannah? 5K? No. 5K? What's your best 5K? 21 minutes? What's your worst usually? Or what's the one that you're like not proud of, but it's like...
I think like 24.
Maybe like 24. Okay. So the input could be the day. The output would be her running. So the input might be the date itself. I'm not looking at numbers for a second, just ideas. Input the day, and the output you would get is the time you ran the race. You input a new day, you probably get a new output, right? A new time it took you. So the concept of relation is that it just compares two things. Something goes in, and something comes in. Okay? Input, output. That's what we're looking at here. A pairing of these values. Now, the value that we input is called the independent variable because it does not depend on anything. It's independent of choice. So here, you could say, you know what? I'm going to pick Thursday. That's my independent variable for the sake of the example we just used. Or I'm going to pick next week on Wednesday. I can change the input. What depends on the input is the time of her run. That's the dependent variable, y. So x and y are different things that act. Now, to give a better example, I'm going to then really got to go into functions kind of ahead of time before we even get to functions. But think about it this way. What's a good example? Oh, here we go. So, how many of you ride the Metro North? How many of you ride the Long Island Railroad? Or have ridden either the Long Island Railroad or the Metro North ever? Okay, maybe a couple times here and there. Thank you. Please raise a hand there. So if you ride the Long Island Railroad or the Metro North and you go to buy a ticket, what does it ask you at the machine? Where you're going and where you're starting, right? Because you could buy a ticket anywhere, really. Okay, so what would you tell me then? The cost of your ticket is a function of what? Distance. Would that make sense? If you travel longer, you pay more. New York City subway. How does that work?
It's just a flat fare.
It's a flat rate. It's a flat fare. It's the same all the time. That is not a function of distance, okay? You with me so far? So, an easy example to remember is that the independent variable would be the distance you travel. You input that into the machine because it's actually a machine. That's why I'm using this example. You literally type in the machine your distance by putting in where you're beginning, and then it calculates distance, or what's called zones. It uses zones, not really distance, but zone distances. And then what's the output? What does the machine tell you? You put in where you're going, the machine tells you, give me price. Give me money. It tells you the price, exactly. So the input would be the locations that you're starting at any out of the distance or zones traveled. The output that comes out of the machine would be the would be the cost itself or the price itself. Okay, and this is similar, I had the word cause in my head, sorry. This is similar to cause and effect. The distance traveled causes an effect. The effect is the cost or the price. The independent variable, the thing that you input, that you choose, is your cause. The effect is the outcome. I also like to use the term width of curve and height of curve, and horizontal axis and vertical axis. So let's quickly draw just the first quadrant. If I have a function that looks like this, okay, doesn't matter what the function looks like right now, I can say to myself, okay, at a value of x equaling 10, what's the value of y? And maybe it would be an estimation. In this case, it's a pretty easy estimation. So at a value of x of 10, what would be the value of y? Well, it's around 5, right? If we look at this coordinate, I go over 10, I go up 5, there's my coordinate. So you could say that the width is what? How wide is this? Please, everybody, how wide is this? Oh, careful. How wide?
10.
How high is it though?
5.
So the width of the curve is the independent variable. Look back up at x. This is the width. This is the height. You see what I mean by width and height on a graph now? The horizontal axis, it simply means go along the horizontal. That gives you the independent right there. Go along the vertical. That gives you the dependent value right there. So independent and dependent is x and y, but it's really what you put in and what you get out. So we use x and y all the time, but maybe, just maybe, this instead is the price of a stock as a function of time. What's the independent variable now?
The price.
Think about it. Doesn't the price depend on the day of the week for a stock? If you look up the price of a stock, what do you have to look up really? The time in which the price was made. The price is, so if you know anything about stocks, the price fluctuates as a function of the economy. So the economy changes as a function of time. So tomorrow, the same stock might be a different value. The next day, the same stock has a different value. So as the time changes, the stock goes up, it goes down, there's been a scandal, then it goes back up, somebody new takes over as a CEO, and then they reach their maximum attainable value and they coast for a while. That could be the stock price. But the stock price, P, is a function of time, T. It's always Y is a function of X. Y is a function of X. The dependent variable depends on the independent variable. Okay, the word itself gives you direction in which you should understand, okay, or how you should understand it. It depends upon the other. All right, let's go back to the concept of relations real quick and differentiate between relations and functions. So we take a look at relations. They can be represented 4 ways. The first way is an ordered pair. An ordered pair simply lists the coordinates. The second way is tabular, a table. You see this right here. The third way is graphically. Notice, by the way, these are all the same coordinates, right? These are using the same data. So you have the data represented this way or this way, the exact same data. Well, these exact same 4 coordinates are now on a graph. Or instead of using a graph, you can use what's called a mapping diagram. Your input, I know this is the one that's most unknown to most students. This one right here. It's a way to visually demonstrate domain and range of 2 different things. Okay, it's not necessarily used much in calculus or anything beyond here. Okay, -2 is the input, isn't it? But what's the output for -2? Yeah, it's 2 or -2 is the output. So look, the input is here, but the output is either -2 or 2. That's why this is showing 2 arrows branching off. 0 has an output of 1, 3 has an output of 1. Those both go there. Okay, 0, 1, and 3, 1. Now, the concept of relation simply means it relates 2 variables, x and y. Let's see how a function differs. Anybody know how a function differs from relation? You can ask that question. You could swipe down and see, but there's one specific difference here. There's one difference here. A function, for each input, you have only one output. Only one output. The other way around is not necessarily have to be true. But for every input, you only have one output. So for example, if x is 2, give me a value for y, Max. Any number. 3. Well, if that's the case, and I plug 2 into the function again, I better get 3 out again. I cannot plug 2 in later on and get a number like 4. Well, look, the same input is 2, isn't it? But doesn't the input of 2 have 2 different outputs suddenly? This is not an example of a function. If the same input can somehow give you 2 different outputs, it's not a function. It wouldn't make sense because now it's not a function of the other thing. It doesn't depend on it. Right? This number does not really depend on this number because clearly it's different each way. So again, you cannot have, an easy way to think about it, you cannot have an x variable that repeats itself with a different y variable. Okay, that would not be a function. That would not be a function. So let's look at this first example. You can see this. Graph the relation simply by coordinates. You can use coordinates and tell whether it's a function. So look at the coordinates and make your axes accordingly. Make your axes accordingly, please. So graph the relation and tell whether or not it is a function. So graphically, you're literally just listing coordinates. Your y values, it looks like they range from 1 to 0, and your x values go from 1 to 4. So I'm going to draw my axis like this. Please get used to this, because some of you are still having trouble with this, I've noticed. Look at your data. Look at your function. Those are what govern your graph. Your graph, its size, its increments are based on the data itself. Because the y variable, the data is very small between 0 and 1. I only went from 0 to 1 there. The x went from 1 to 4. So I plot all of these. I've got 1, 1. I've got 2, 1. I've got 2, 1/2. I've got 3, 1/3. And I've got 4, 1/4. Is this a function? It's a simple test. Think about what a function means from the previous slide. Is it a function? Explain why or why not. Is it a function? Why or why not? Bridge, go ahead.
I don't think it's a function because it's in the number 2 column. There's more than one output, so it can't be a function.
Exactly right. Well done. Okay, again, the input of 2 has an output that differs for each of these coordinates. You can't have the same input with 2 different outputs. Where are those coordinates on the graph? Where are they? Do you see them? You see them, right? 2, 1 and 2, 1/2. Everybody sees them? They're right here and here. How are they aligned? You would say they're aligned. What's the word? What are they aligned? Vertically. Vertically aligned. Interesting. Have you heard of something called the vertical line test? Did you hear about this in your earlier classes? Possibly. The vertical line test comes about because when a function, or I shouldn't say that, when a relation has 2 coordinates that are stacked vertically, it means that the same input of 2 had 2 different outputs. The input of 2x had 2 different outputs. You can't have that for a function. So if you could ever take a vertical line, and I'll show you what I mean. If you can take a vertical line and pass it over your data, and if it intersects more than one coordinate, here it intersects one coordinate, here one coordinate, here one. But look here. How many coordinates does it intersect? 2. If it ever intersects the function twice, or 2 different coordinates, you know that it is not a function. I shouldn't say function, geez. If it ever intersects the graph twice, if a vertical line ever intersects a graph twice, it simply means you have multiple outputs for the same input. And that can't be true for a function. So you could say that this fails the vertical line test. Let's see what it looks like on the next slide. The first example on the left is a function. Take your pen, please, if you need to. I used to say this, take your pen and move your pen along. It only intersects with this curve once everywhere we are. But look at this. As soon as you put your pen down, it intersects twice. Over here, it doesn't intersect at all. But you need to test all values. So on the right side, you can clearly see that there are 2 intersections. Those 2 intersections are indicative of the fact that this is only a relation. This is not a function because of these 2 intersections. Questions on the vertical line test. How many of you are seeing this for the first time? Just be honest. It doesn't matter where you are. I just want to know. Vertical line test. Okay. Does it make sense, the concept? If you intersect twice, it means you have 2 outputs for the same input. And we can't have that. So as soon as you intersect twice, you say it's not a function. It's not a function. And the way you can tell is if you wrote down the coordinates. Here's this coordinate. Ready? 2, 2. Here's this coordinate, 2, -2. Well, look, isn't the input 2 the same? Yet there's a different output, 2 and -2. Ooh. Given the following function with the following domain, first, find the range, then graph it, and then finally, is it a function itself? Okay, given the following, I should say equation here, really. Of a given domain. So I don't want you to graph this. It's a parabola. We'll talk about that later in the year, but I don't want you to graph the whole thing. I want you to graph the 4 coordinates. You're given the 4x values for the domain. Find the 4y values, please. Find the 4y values, please. you want to be quick about it, you can plug it in your calculator and go to your table if you like. You can type the equation, y equals 2x squared minus 3x plus 5. You can type that into y1 and use a table. I'll do that on my computer so you can see what I'm talking about in a moment. Again, all you're coming up with is 4 values for y. Switching over to the computer so you can see what I'm doing. If you're done, just look up so you have an idea. I really only want you to do part A. I mean, obviously part B, you're just going to graph those 4 coordinates. And then in part C, you're going to decide if it's a function or not. But here's how you would do it on your calculator. By the way, on your next test, you're going to have part of the test calculator, part no calculator for certainty. Because I'm going to ask you to do things like set up the function and show me the matrix. And then later on, if I ask you with the calculator to solve for the matrix, you can use the calculator for that. But I'm also going to ask you to solve a system using a graphical method and use the solution set range and stuff. So part of this is going to be no calculator. The part that does have the calculator, though, you could use this feature. You type this into y equals by press y equals, and then type in the equation itself. Press second, and hit table. Now, these are all arbitrary values I've typed in the past. I can delete them all because of the fact that I have my table set up this way. Some of you probably have numbers like 1, 2, 3, 4, 5 already there. Here's how I make it so that I can type in a value. Press second, and then table settings. And then choose ask. Oh, look at this. Independ, depend. What do you think those represent? Independent variable x, dependent variable y. So I want to ask the calculator some values for x. So make the independent variable ask. Go over to ask, hit enter. What that will do is that will clear out all the x values in your table.
How do I get out of the exponent?
Press to the right. Got it? So again, press second, hit window, which brings up table settings, and change the independent variable, the x variable, to ask. So now when I press second and go to my table, I can ask the 4 values that I needed. I needed values of -3, -3, enter, 2, enter, 5, enter, 7, enter. Check your answers. You should have gotten 32, 7, 40, and 82. Well, it depends on where you want to go. Where can you go to the table next? Where's the table? Second graph. Again, once you set up your table settings, press second and then hit graph to bring up the actual table itself. So your table settings, to get to those, press second and then window. After you've got it looking like mine, this is all that matters right here. That needs to be on ask. Second, graph. I typed in these 4 numbers. You need to type them in yourself. Making sure to use the negative key down here at the bottom. Please use the negative key. Don't use the minus key. I don't know if it matters actually there. Doesn't matter? Let's see. Yeah, it does. See syntax error? And then go to the error. And it tells me you can't use a minus sign. You're crazy. So you change that to a negative sign, and then it suddenly works. Okay, so 32, 7, 40, 82. 32, 7, 40, 82. So my range, part A, is simply 32, 7, 40, 82. And my domain is -3, 2, 5, 7. Yeah, go for it.
I have a question for 5. Like, if you put it on calculator, you get 40, but if you like really solve it, like,
It's
oh.
40.
You just made a mistake. Go check the solution. Check it again. You gotta do 5 squared first.
So it'll be
25 times 2 is 50. 50 minus 15, and then plus another 5. You got it? Yeah. No problem. It should always be the same. So if you have a discrepancy, just check your work for that. So if you graph y, like it says in part B, I need to go up to 80 on the y-axis and all the way to negative 3 along the x. Here I need to get to 80, so I'll go by 20s. Take a look. As long as I label one increment, I know the rest. Is that clear what I'm saying here? I only need to label 1 and 20. The rest will be 2, 3, 4, etc. For those of you that have not been labeling anything, you need to label. You need increments, or else it's not known what you're graphing. So you need at least one number to establish a pattern. Once you put a 1 there, I know the next number is 2. Once you put a 20, I know the next number is 40. Okay, it's always going to be double the previous one, or 1 successively up. 20, 40, 60, up by multiples of whatever that first number is. So simply graphing this, negative 332 is going to be around here. 2, 7 is going to be all the way down here. 5 is going to be all the way up. 3, 4, 5. 540 is going to be over here. And then finally 782 is going to be up here. Look at your 4 coordinates. Any problem at all? Any issue? It's not a line. No, that's fine. I'm saying no. Yeah. It's not a vertical line, but I'm saying, is any vertical line going to cross 2 coordinates? No. So you say it passes the vertical line test. So it is a function. It's also obvious from the data alone to see that this is a function. The data alone tells us it's a function. Because look, do any of your x values repeat? Any repetition in the x values? Any? None. So that means that there's not going to be a double input with a different output. We don't have to worry. It will definitely be a function. Part C is yes, it will be a function. Okay? Now, keep in mind, please, that the x values are the domain and the y values are the range. Domain, range, domain, range. Because the next example, we're going to use that terminology now. So we look at this example. Determine or give the domain of each function. Give the domain of each function. So we've got 4 functions. Here's where you have to actually think outside the box. We're going to have to think about some restrictions. It's not obvious what those restrictions actually are. Okay, it's not obvious. But it's a little bit difficult to see here by looking at this just directly. Give the domain of each function. How about the first one, part A? What would restrict our domain for part A? Would any values make this not possible? No. Good answer. How come?
Because the only possible thing is around here is x squared plus 4 equals to 0.
Correct. Why?
Because
You can't what?
you can't divide it by 0.
You cannot divide by 0. You guys remember that, right? Division by 0 is undefined. So the denominator can't be 0. But could you somehow make that denominator 0 for part A? Is there any number you can think of that would make that 0? Pick any number for x. Whenever you square a number, it always becomes what? So you're going to have a positive plus 4. Is that ever going to be 0? A positive number plus 4, is it ever going to be 0? Of course not. Only negative 4 plus 4 would give you 0. So Ashley is absolutely right. The first problem, the domain is all real numbers. The domain for the first problem is all real numbers. You can write out those 3 words, or you can write the following. This means the following. X is contained in the set of real numbers. Real number set is drawn with like 2 vertical R's slashes. See those 2 lines? That's not a typo. It's not a mistake by me. X is in the set of real numbers. It's just the way to see it. You might see it in like a textbook, but if you wrote all real numbers in the test, that's fine with me. Part B. Mr. Brown, help me out. What values of x would make this denominator 0? You're good with intuition, that's why I asked you. You're able to see stuff. Negative 2? Yeah. Absolutely.
And 0.
And 0 or 0, either one. Negative 2 and 0 are not going to work. Plug in negative 2. You get a 0 times negative 2, which is 0. Plug in 0. You get 0 times 2, which is 0. So if you set the denominator for number 2, or part B, you say that the denominator cannot equal 0, we can see that, well, x can equal 0, and x can equal negative 2. Those are the two things that would make the denominator 0. So if you're writing out your domain, you could say all real numbers except for 0 and negative 2, if you want to. You could write your domain in interval notation. You could do this.
Can we write like x does not equal like the equal sign attached to it?
So either one of these interpretations, yes, is good, okay? So look at the first way to write it. The first way to write it is, it's lengthy, but it makes sense. From negative infinity to negative 2, you're all good. At 2 and negative 2, we got a problem. From negative 2 to 0, we're all good. At 0, we got a problem. And then from 0 to infinity, we're good. Okay, that's interval notation up top. And this is just really, I mean, it is set notation technically, but set notation would be with inequalities. And again, you could also write the words, all real numbers except 0 and 2, and negative 2. How about part C? Part C is a bit tricky.
Is it anything but negative numbers?
Good. You can't have negative under the radical. So therefore, the radicand, here's part C, has to be 0 or what kind of numbers?
Positive.
So we say greater than or equal to 0. Again, think about it logically for part C. Underneath a radical, you cannot have negative numbers. So whatever is under the radical has to be 0 or positive. What numbers are 0 or positive are numbers that are greater than or equal to 0. So whatever is underneath the radical in part C, you simply set that greater than or equal to 0 and solve. Add the x over, you get the following statement. And what does this tell me? Really, this means x is less than or equal to 2. Try numbers. Try numbers, please. By all means, try numbers. Pick a number that's not less than or equal to 2. What's a number that's not less than or equal to 2? Give me any example number not less than or equal to 2. 5. Okay, plug 5 in part C. You get 2 minus 5. What is that? 2 minus 5. Negative 3. If we take a square root of negative 3, it's not a real number. We'll talk about what that number is a little bit later down the road, but it's not a real number. So a number like 5 will not work. Yes, Annette?
What's a radicand?
A radicand is the expression underneath the square root. And the square root is called a radical. The square root symbol, this thing, is called a radical, and the number or expression underneath is called a radicand.
So 2 minus x
Is the radicand.
Radicand sounds like a Pokemon.
Is it?
Isn't there a Pokemon called Raticate?
I don't know, it's possible. I don't know Pokemon well. I know Dragon Ball Z really well. I'm not a Pokemon person.
Yeah, Raticate.
It's like F, G,
Oh, so I didn't even go over that. Thank you. That's a great question. So George poses the question, what's going on with these variables next to x? So functions are written as f of x or h of x or g of x instead of y. Remember earlier in the year, this was y equals? Each one of these, we had this. Y equals. Y equals. Instead of writing y, we can name functions with another letter. And sometimes you could use the letter of what it means. So if I'm looking at cost as a function of production number, it would be C of n, and n goes here. Cost as a function of n being the number of production particles produced, or objects produced. So this is simply h of x, g of x, k of x, f of x. Those are other ways of writing the variable y. That's all it is. But you're writing it as a function because this is indeed a function. It could be anything. No. It could just be anything, any letter. It usually comes from whatever the problem is dealing with. If the problem is something like population as a function of time, it might be P of t. Population as a function of time. So P parentheses t, and then t down here. So P of t is your y really, and t is your x. Okay? Good question. I should have mentioned that. Thank you, George. How about the fourth one, part D? Part D is very similar to part C, but there's some difference in it. You have a radical still, but where is that radical? Physically, where is it? In the denominator. What can I not have in a denominator? So now, instead of writing greater than or equal to 0, just greater than 0. Again, think about it for a second. Pause. Underneath the radical has to be 0 or positive. But since the radical is in the denominator, it can't be 0. So what's underneath that radical there has to simply be positive. So it was 2 over 2x minus 8.
Wait, so
Go ahead.
if x equal 2 and you get 4 minus 8, you square root of negative 4.
You would get, if x equals 2, you get 4 minus 8. That's negative. It's not going to work.
Yeah, so isn't it the answer to it x greater than 4?
Let's figure it out. Let's go through it. We set the radicand greater than 0 because, again, it's got to be positive or 0 because it's under a radical, but because it's in a denominator, it can't be 0. So this is really saying this has to be positive. This has to be positive. And then when you add 8 over and divide by 2, you're going to get x is greater than 4. X is greater than 4. So yeah, 4 doesn't work.
With the answer.
Yeah, okay. 4 doesn't work, right? If you plug 4 in, you're going to get 0. But anything greater than 4 will work. Try 5. 5 works, you get 2 under the radical. Try 6, you get 4, etc., etc. Okay, so take whatever you have here and set it greater than 0. So this is your domain for this function. Why is it important to represent a domain? Please, do me a quick favor. Do me a favor. I need to prove this to you. Don't think I'm crazy. Go to your calculator and type this into your calculator here. 2 over the square root of 2x minus 8. You might run out of time at this point, just to give you a heads up. 2 over the square root of 2x minus 8.
How do we do the over? Can we just do division and that way?
I'm not going to have you finish this tonight with a video. I'm going to continue tomorrow with this actually. What did you say?
Nothing.
Over is division. Is that what you asked?
No, yes.
Here, I'll show you online, please. 2 over, parentheses, second square root, 2x minus 8, close, zoom 6. Look where the graph starts on the x-axis. It's going to start right here at 4.
What?
Isn't that 4 right there? And then isn't it everything greater than 4? Notice,
That's
the
meta.
graph does not exist for values of x that are less than or equal to 4. Our answer we got was x is greater than 4. Look at the graph. It starts at 4 and it's everything to the right. Okay, the domain is really saying where is the graph going to be acceptable. So tomorrow I have you guys, right? Yeah, day 6 I don't.
Yeah.
So tomorrow I need to finish this section and I'm going to jump right into section 3.9. Is that clear? Okay, so you don't have homework tonight that's due tomorrow because I really didn't finish it and I have a good amount to do so. I don't want you to watch all of this. This is stuff that I want to talk about a lot. So tonight what you can do, maybe do all your problem sets that you can do so far. Because keeping in mind that your problem set is due when?
Friday.
On Friday. Okay, tomorrow we're going to finish up this section and we'll do 3.9. That problem set we'll do on Friday. So do all your problem set at least tonight except for 3.8, 3.10, and 3.9.
Just the problems that's due.
Friday. It's always the class day before the test. And since the test is Monday through Friday. Yep. What's up, Nick?
Does this look okay? Because you can't really see a lot, but I don't know how else to represent it.
Yeah, you're good. I mean, so it's that region, obviously, right?
Yeah.
Yeah. So where you have the overlap of several colors is the solution region. That's fine. Yep.
Can you tell the numbers? They're kind of covered.
Okay, fine. That's good. Yep. Thanks, Kate.
Rainbow's not here today. Right. Is she not here? Yeah, she ain't here. Really? A lot.
Teach this. I think you're really going to understand it. Given a graphical function, just determine the domain and the range of that function. So before we get to this at all, first tell me what domain is again. What is domain?
It's the x values.
The values that x can take on. Very good. The x values. And range? the y values. So I look at this graph and I think about this. And here's the easiest way to do this. And I know you probably get it right away, but just to visualize. Imagine, if you will, that you took a flashlight. Okay, and this is kind of weird, but it actually does work. You took a flashlight down here, and you shined or shone the flashlight? Shine? Shone? Which one is it? I don't know. Shine the flashlight? Past tense, I want to say. Shone? You illuminate. You illuminate the graph with the flashlight. Very good. And imagine the flashlight were pointing in this direction, right? That's what the flashlight's rays of light would look like. We assume that light travels in parallel direction, the waves. Although it really doesn't. If this were the case, and this flashlight were shining, we would see that it would continue, the light would show up here, the light would show up here, but the light would get blocked. Wherever the light gets blocked is where the domain is. Now, at this point in time, though, we'll notice that this last one that we drew, although from below is not getting blocked, from above it would. So we kind of have to stop right there. So take a look at where the flashlight intersects the function. For those values that is not touching the x-axis, that's your domain. Your domain is from -5 to -3. Because the light or the rays, it would be a shadow there. Where would the shadow occur, pretty much, is what I'm saying. The shadow would occur from -5 to -3. Stay with me for a second. I know it's weird. I'm just trying to give you an alternate way of understanding. Because domain and range, some people just really struggle with. Take that same flashlight, slide it over here now. Again, I want to see where there's a shadow on the x-axis. Well, it looks to me like from here to here, this would all be a shadow. No light rays would get through. Because again, follow the light rays. They would get through here, they would get through here, they would touch the axis, but here, that would be like a barrier. It acts as a barrier. Okay, again, I'm looking at only below the axis right now. So I could say my domain exists for those two locations of blue. Well, if I do the same thing from above now, from above, what I'll see is that from here all the way to here, it's also part of the domain. It's also part of the domain. Again, it's like having my iPad here, okay? This is empty. I shine the flashlight above. Where would the shadow be? Imagine the rays were parallel, right? Okay, I know they do spread out. If the rays are parallel, the shadow would be directly below the iPad, right? Wherever the shadow is, that's where the domain exists. And that's what we're seeing here. If I shine this flashlight from above up here, the light rays would all come straight down. It would hit the axis, and then there'd be a barrier. This would all be a barrier the whole way. So what happens is, the locations where the shadow would exist, where the barrier would stop the light rays, is all shaded in blue. It's all shaded in blue. So if I were to write that in interval notation, I would say it goes from -5 to -3. Why did I put different symbols between or outside of -5 and -3? Why did I do that? Only one person sees that? Come on. Why did I use a parentheses for one and a bracket for another?
I think, was it because it's infinite? Or I remember in the earlier lesson we learned about this.
Yeah, infinite would have a parentheses, but that's not this case. It's not doing infinite. Next. Look at your graph, please. Look at your graph. Open circle at -5 means the light would go through it, wouldn't it? Again, think about the flashlight. I know it's ridiculous, but think about it. The light would go right through this open circle, and it would hit -5. Remember, wherever the shadow is where the domain exists. So the domain exists from -5 to -3, not including -5. Then the domain exists from -2 all the way to 3. Even though it looks like it's two separate parts, it continues. This function is continuous, so it takes on all the values from -2 all the way to +3, not including those endpoints. That's your domain. Again, it's a weird way of interpreting it. It really is. But think about what are the values that x can take on in this graph. Pick any number in the answer we just wrote, and you could have an x value on the graph. It shows up. So pick a number outside of that range. Pick a number outside of the range of answers. I don't care what number. Pick a number that's not in the answer set.
4.
What do you got?
4.
4. So I go to 4 on my axis. Here's 4. I take this value of 4 and I look up. Is there a function? I look down. Is there a function? Why not? Because 4 is not in the domain. Again, go to that location, look up and down. If there is a function either up or above or below it, it's in the domain. So give me a value that's in this domain, Max. Pick a number in the domain.
Well,
2. So I go to 2. I look up. Please follow what I'm doing. I look up. There's nothing in the domain, right? But I look down and what do I see? There's the function value right there. The coordinate 2, comma, negative 1.5 looks like it's right there. So all you got to do is pick a value and look above and below. If the function is there, it's in the domain. If it's not in the domain. Okay, so all these values from negative 2, if I look up, the function is here at all these spots. Here I look down, there's the function the whole way until I get outside the number 3. Ash, question? Did you have a hand?
No.
What do you think I'm going to do for the range? Take a guess. Take a guess for the range. Use your intuition.
Same thing, just from the side.
Yeah. Imagine if you have to. You don't have to use the flashlight anymore if you get it now. Forget the flashlight, obviously. It was just to give you an idea. But imagine now that you're looking from the right and left. If I were to shine a flashlight over here, I'd be looking at rays that are coming this way. So that would not be in the range. That would not be in the range. And then suddenly I hit a barrier. That's part of the range. That's part of the range. These are all parts of the range. All the way up until here. Now at this point I have to go to the other side of the axis to see what else. Remember? This hits the axis. This hits the axis. So remember, wherever my light rays intersect my function, in this case, from 1 all the way down to negative 4. That's where a shadow would appear on the y-axis. No light rays would pass through that function. From the left-hand side now, I have to do it also. All of these rays are going to come and hit the function. Here's a barrier. There's a barrier. These are all barriers. These are all barriers up until there. Then the light ray hits the actual axis. But again, over there, it's already included in the range from the other side. Here we have a barrier. Here we have a barrier. That's good, but it's already there. Again, there's already a shadow right there. So it looks like in this example that we have an overlapping shadow from here to here on the left-hand side. And on the right-hand side, if I think about this, my shadow goes from here to here. But on the left-hand side, it goes from here all the way down to here. So this range, look where I'm pointing, please. There's an overlap right there. Again, it's in the range because of this value. It's also in the range because of this value. So how does this one work? The same way. You find a value along the y-axis, look to the right and left. If I pick the number 5, I look to the right. Is there anything there? I look to the left. Anything there? So is 5 in the range? No, it's not. And that's why it's not shaded red. So my range goes from negative 4 all the way to positive 4, not including the endpoints. This is not a coordinate. Please write that down. If you need to write that down, write it down in big letters. This is not a coordinate right here. It looks like a coordinate, so please don't confuse it when you're studying later. This is not a coordinate. How do I write this in interval notation, in set notation? Negative 4 less than, not less than or equal to, just less than. Y less than 4. That's another way of writing the range, if it's more clear, because I want you to see that these are the same thing. Can I give you an example to practice on your own so I know that you know what you're doing? Okay, I'm going to draw one. It'll be pretty simple. So let's say we've got an example that looks like the following. I will give you coordinates, so the axis doesn't really matter as much as far as grid lines. Just so you can see where that lines up. So just to give you ideas of where things line up, this one lines up right here. This one lines up here. It lines up directly. I'm going to the nearest integer, okay? I did that on purpose. So please round to the nearest here in this case. That lines up right there. This lines up here and here, here. This one's going to be about a halfway down on that axis. This is lining up perfectly. This one lines up perfectly. What would the domain and range for this function be?
Wait, is the x-axis in equal to
Sorry, that's a really good question. They're very good. See? I didn't put increments. Thank you. Let's assume they're both 1 for now, and you're right, I should have written that. If it helps you, some students in my other classes like to give coordinates to the endpoints. That might help, because it tells you the x and the y value, or the domain and the range at the endpoint. It's useful to have that. So if I were to label these, this would be -4, -4. This would be -2, -2. This would be -1, -0.5. This would be 3, 1. This would be 4, 5. I'm going to give you a label for the minimum value here, just so you have it. This would be, let's say, 6, 3. And then the other arrow goes off forever. See the arrow on the top right? That continues. The function goes on forever. So think about that when you're giving your answer.
So if you did flashlight, it would go up and block out.
Forever.
And like
Oh, no, yeah. It would block off sections at a time. That's what you need to figure out.
1, 2, 3.
So think about your horizontal sections that you have, and then think about your vertical sections of the graph you have. Try to come up with the range and domain on your own real quick. And we'll go over them. Since when has this water fountain been broken out here? A while now?
Yeah.
Anyone knows? Has it been a while?
Yeah. I've noticed for a while. I honestly thought they were shooting.
I want to get water on my here and I'm thirsty. Third floor. I think the domain is easier in this problem to get than the range. I think the range could be a little bit tricky. A little bit tricky. You want to give me some piece for the domain?
Oh, I was just gonna ask.
Any question?
Yeah, when you're like writing an algebra solution, like do you always write like x equals d or like?
Do you ever what?
Like in the one before you have like
D equals and R equals. D for domain, R for range. And your interval can be given in interval notation or set notation is fine. So go to the first, I'm going to give you another approach in case you've been confused. Ready? Go to the first endpoint and draw a vertical line from it. Go to the next endpoint, draw a vertical line from it. That will give you the domain for the first part. So for the first part of the domain, we know we're going from -4 inclusively. I need to put a bracket here. All the way, in this case, to -2, not including the -2. Take a look at the first part of the domain. See if you got it right, please. That's the first part of the domain. I've highlighted it on the graph. Again, if it helps you, you shine a flashlight from below. This is where the shadow would occur from here to here. This would all be a shadow right here. So from -4 to -2, including -4 because it's a closed circle, not including -2 because it's an open circle. Now, in the next part, this one you almost couldn't confuse because these are the same exact coordinates, right? Notice that? You almost can't confuse it. Here, though, for the next piece, I have to consider from here all the way to here. And this is approximately at -1 for x, and this is going to 3. Now look at the x coordinate here, and I see it's -1 all the way to 3, including -1 and 3 both. Does that make sense for the second part? Yeah, ask. It does, but not in this class. The other one means, so this is called the union of two sets. The other one is like the overlap of two sets. It's an and versus or statement only. But yeah, it's always written this way for interval notation for a domain or range. It's always written like this. So the second part, again, what do? I look at my coordinate here, and I look and I draw a vertical line from here, and I draw a vertical line from this one, and I see that those vertical lines intersect at 1 and 3. Okay, then I go to the next part, which is up here, and I draw a vertical line. What is it going to intersect with? 4, the x-coordinate of that point. Now, this goes on for how long? Forever. So from 4 all the way to infinity, not including 4 or infinity. Parentheses always. That was what you were talking about earlier. That's what you misconstrued earlier. Next.
Does it matter the order in which that?
It doesn't, but from lowest to greatest is always the way you write it. Traditionally, you write it always things from lowest to greatest. But technically, it doesn't. But if you want to be nice and you want me to not be like, oh my God, really? Just put it in order because it makes more sense logically. You would never, it just doesn't make sense not to, right? Again, it's not wrong, though. It's not really wrong. How about the range? Just to show that last one, by the way. Here's my vertical line from that point. And then, again, that goes on forever. That's why we went all the way to positive infinity. For the range, I really need to kind of erase all those vertical lines. I'm just going to use a different color. I'll use blue. For the range, I do the same thing. Draw a horizontal line from here and here. So what do you notice about the beginning of the range? The very beginning of the range. It's the same thing as the very beginning of the domain because those coordinates were actually identical in x and y value. It's not changing. And then after that, it's changing. So I go to the next coordinate. I draw a horizontal line from here, a horizontal line here. That means that one's going to go from what looks like negative 0.5. That's the y value. Where do I get that? Right here. The y value there is negative 0.5. The y value here is 1. That's the y value we wrote down as 1. That's that value. And those should both be brackets, really? Why does it need erasing? There should be a bracket here. And then how about after that? How about the next part? Kate, what do you got?
I did bracket, 3, comma,
Yeah, very good. And Kate said, you know what? I'm not going to let that open circle confuse me. Right? See that 4, 5 there? The 4, 5 is the part that can confuse people. But if you think about it, the range, again, if I draw a horizontal line from where the function starts, which is at this minimum value, the function starts here in range and it goes up forever. Yeah, it goes up, it goes up, it goes up, and it kind of stops. But look, doesn't this go up forever actually? So in reality, this is from 3 all the way up. It will keep going up. The range will go on forever in that direction. So from 3 to infinity. Okay? This will take practice, but the idea behind it is the same for any type of graph. If you're looking at a graphical domain and range, that's the same approach no matter what you have. Okay? Yes? Ask? You can keep giving me a look, so I want to ask you a question. You sure?
Yeah.
Okay. So we get domain, we get range. We could do this with coordinates also. Instead of functions, you would just list their x and y values.
So would this be like an example of like the speed limit thing? Like you can really go like 55 to 45?
I was just referring to the fact that the speed limit is an interval, and these are intervals, exactly. They are intervals. So it's along the same lines that things are usually on spectrums of answers. They're not just one answer. Okay? All right, that said, let's go to this next idea. We're going to take example 6. We're going to look at this algebraically, and then we're going to apply this graphically. So algebraically, how many of you, show of hands real quick, have seen something like this? Look at examples A, B, and C. Find the indicated value of A, B, and C. How many of you have seen something? Okay, so let's go over what this means. Let's go over what this means. The function f of x is defined as 2x plus 1. But the problem says find the indicated value. Find the indicated value. What does this f2 mean, part A? Who can explain that has done this before?
I think that the x is replaced by the 2, so you can plug the 2 into the other side. Yeah.
Not really solve, and Evaluate. Okay, that's exactly what it means. When you see a function with a number in it, it means the following. You use the word of. F of 2, F of 3, F of 4. It is not multiplication. If I see multiplication on the test, I'm going to lose my mind. It's going to make me think that you don't even, like, you're not listening or paying attention. Last year I did see that on 1 or 2 tests, and I was very upset. It's not multiplication. Okay, get over the idea of multiplication here. Multiplication with variables, you would see 2f. You would not see f parentheses 2. That's why, remember earlier, Max, you said it doesn't matter how you write it. The way you write things is so that you understand the way that the context is. If I were writing f times 2, would I write f parentheses 2? No, I would write 2f. And you've adopted that knowledge that the coefficient usually goes in front of the variable. So if f were a variable, it would be written 2f. And that would mean multiplication, 2 times f. F parentheses 2, please don't confuse that with multiplication. It's not the way you write it. And I know parentheses do mean multiplication, but with a variable, you wouldn't use a parentheses there for multiplication. This means f of 2. So simply plug a 2 in for x in the function f. So, very simple. I'll do the first one so you can see. I repeat the function for f, and I replace x, which was up here, with 2. Okay, that's all you're going to do. So this first one is simply 5. Do the rest real quick. When you get to number, or part D, think about what part D would work as. Part D is a little bit trickier, but A, B, and C you should get like that. A, B, and C should take you 30 seconds altogether. 30 seconds altogether.
For D, that is multiplication inside of that, right? Or not?
It's not, actually. It's not. D is not multiplication. Okay? D is not multiplication. Think about what that could mean. Right? I know it's not obvious, but you might be able to figure it out. I'll give you a hint. Work your way inside out. For part D and E and F, work your way inside out. Now, part F, Tristan, is multiplication. Right? You see the 2 times. Literally, you see the times. What was B? George, what was B? What was your answer for B?
I don't really understand something.
Okay, so if a function is written as f of x, it means that something is a function of the variable x. So it's normally y equals. When it says f of 2, it's saying, what's the y value when x is 2? So for part B, it's saying, what's the value of the function when x is negative 3? So you take negative 3, and you plug it in to the actual function, and you get the value of the function. It's the y value. That's all it is. So I need you to take negative 3 for part B, and plug it in for x in g's function, because you're doing g of 3. That's all you have to do. So what do you get when you plug in negative 3 into the function for g?
Is that the first one?
You could do this in your head. Come on, look at g. It's right there.
Okay. So g negative 3, like parentheses, equals 9 minus 3.
Yeah, that's all it is. It would be negative 3 squared minus 3. That's what g of negative 3 is. So it's going to be 9 minus 3, which is simply 6. How about part C? Part C, what do we get? Luke?
Negative 3.
We got f of negative 2 is 2 times negative 2 plus 1. It's going to be negative 4 plus 1 is negative 3. All you're doing is plugging in for x. Okay? It's something new for sure, but the idea is this. Imagine I had a function that said C of n, the cost of something as a function of the number of products you manufacture. And I say, determine the cost if I manufacture 37 items. That's what n is. N is 37. You plug that into your function and you get the cost. So this is just a generic function. F of x in this case might be the cost as a function of minutes used on your phone. It might be your weight as a function of your age. Who knows? maybe it wouldn't make sense mathematically, right? So you'd have to actually look at the nature of the context to see what the problem is referring to. So we're going to see word problems with this in section 3.9 that kind of apply this a lot more than just plugging into a function. Part D, how would I approach? Annette, what do you got?
So you find the answer for g of -3, and then that number would be used for f.
Why g of -3? Where is that coming from? Tell me. You're right, Annette, but where you got the -3?
Wait, sorry, I'm thinking f of -2 is -3 is the answer.
So let's pause. Everybody say that one more time, nice and slow.
So f of -2 equals -3.
Didn't we get that in part C? Part C was finding the function value of f when x is -2. So that inside there is really just -3. And then part D is really saying then, okay, fine, really, this is saying g of -3. Because f of -2 is -3. Seeing some confusion still. Again, f of -2, this is substitution method. F of -2 we did in part C, right? And part C, the answer was -3. So Annette said, take a -3, replace this circled spot with -3, becoming this. And didn't we also already find g of -3?
Yeah.
Where did we find that? Right here. So the answer is just 6 for part D. We did a function of a number which was then used in another function. Try part E. Part E is not as simple because you have to plug the 5 in. You can't actually just use the previous answers. Try part E. So like I said, my hint was inside out, right? That was where my hint was that. Work your way inside out. What's g of 5? We're on part E. What's g of 5? Give me the intermediate step. What do you get when you do g of 5? 22. I would agree with that because it's 5 squared minus 3, which is 22. Again, do this first and get a number. Then work your way out. So g of 5, when plugged in up here at the top right, is 22. F of 22 is going to be 44 plus 1, 45. Does that make sense, what I'm saying? It's new for some, it's not for others. So if it's not new, I get it. You're like, dude, I've done this before, all right? Seriously. It's probably boring you. Move on to the next thing if it is, because I'm seeing a little bit of a glazed look in some people because you've probably done this. Try part F at least. Try part F. How would I plug a function into another function? No numbers given this time. No number. Tell me, Max, what's double f of x? What expression would indicate, or what expression would be replaced there for double f of x? Well, what's f of x first? Look at f of x.
Okay, so it's before.
There you go. Take a look, please. Look up. The question said double f of x, right? So you take this whole function and double it. When you do that, you're going to get 4x plus 2. Does that make sense so far? I'm literally doubling a function. Okay, f of x is represented by 2x plus 1. Double that would be 4x plus 2. Now here's the tricky part. I got to take 4x plus 2 and put that into g. Where have we been putting in the number the whole time when it's been a number? Where have we been plugging it into?
Put it into x.
Yeah.
But I think maybe x squared is 4x plus 2.
This has to go in for x still, where x squared is. So we're going to have this quantity now being plugged in right here for x.
Is that squared? Or
Yeah. So this is going to become 4x plus 2 squared minus 3. Again, where is this coming from? Let me show you. This part here is really replacing this x. Again, we don't want g of x. This is g of x right here. Everybody look, this is g of x. We want g of 4x minus 2. So take 4x minus 2 and replace x with that, becoming 4x plus 2 rather, squared minus off this 3 because this is minus 3 at the end over here. So the minus 3 here is the minus 3 over here. You could simplify by foiling it out. 16x squared plus 16x plus 4 minus 3. 16x squared plus 16x plus 1. So is your answer a number? Did I do it wrong? You all have your hands up. Oh, you shot your hands up like, oh, geez.
No, you did it right. It's just, you could, when you're doing it, you square the first variable, square the second variable, and multiply inside when you're squaring it.
As long as you FOIL, yeah, but you have to multiply the inner two and then double that number.
Yeah, that's what I do.
Yep, that's fine. It's the same. That's what FOIL is. Yep, very good. That's if you have a binomial squared. If it's like x plus 2 times x plus 7, you got to actually FOIL it out.
Why'd you get 16x squared and then plus 16x?
How do I do this? It's really 4x plus 2, 4x plus 2. Remember FOIL? Did you learn FOIL yet?
No.
So if you have a binomial like x plus 2 times another binomial x plus 3, it's called double distributive. Don't worry about it right now. We're going to actually cover that as a topic. If you've done it, you've done it. If not, I won't make it work like this on the test, so you wouldn't have to worry about it. Okay, but what's happening there is you're taking this quantity and multiplying it by itself. It's called double distributive. If you just literally YouTube the word FOIL method, you'll see it's very simple. It's called first, outer, inner, last. Some teachers teach it as box method. Some call it double bubble. I've heard that term. That's a new one. I've never heard that one. So everybody's come up with a new way to call things. The original way was called double distributive. The original was double distributive, but then FOIL came about when I was in high school. First, outer, inner, last. Yeah.
Do you call the opposite unfoil?
What is it?
Unfoil.
Factor. Unfoiling is factoring. Really. Yeah. But I've called it unfoiling before. I'll tell students, do the opposite of foiling. That's what factoring is. Okay, so evaluation of functions means you replace x with whatever's inside of the parentheses. This last part is going to be a little bit tricky. No functions anymore. Now it's a graph. But we're still doing the same thing we just did. We're still doing the same thing we just did. If I want to know what f of negative 1 is, that means what? Answer that question first, please. Can anybody answer this question? What does f of negative 1 actually mean I'm looking for?
Is it, just a guess, is it like maybe like the slope?
Not the slope. Earlier, when we said f of 1, we plugged 1 in for x, didn't we? We're looking for a value, okay, so a point. Be more specific, I need more than that.
A point on the graph that will show us, like, if negative 1 is x, what is y?
Very good, that's exactly right. If negative 1 is x, what is y? Remember, this f of x, a function, is really y. This is saying, find y when x equals negative 1. Write that down if you didn't know that, please. That's all it says. I know a couple of you know it already. Dang, that was quick. Find y when x is negative 1. When x is negative 1, what's the y value right here? Look at the coordinate. I just put it on the graph. The coordinate for the y value is? The y value? 1. When x is negative 1, the y value is 1. So the first one, the answer is just simply 1. G of negative 4. I go over to negative 4. I go down to g. What's the y value here? Negative 2, etc., etc., etc. Okay, if you need to see this one, to see it more, look at the last example in the video. So clearly we didn't get through this. We didn't get to the next section. So tonight you're doing the 3.8, 3.10 homework, which is only out of section 3.8. Is that clear? Only out of section 3.8 here.